deep beneath your feet, 4,000 miles down. Scientists have found something that shouldn't exist. Giant blobs of molten rock, the size of continents, lurking in Earth's mantle like sleeping giants. A mysterious new layer hidden inside our planet's inner core. And evidence that the very heart of our world might be cooling faster than we ever imagined. If these discoveries are correct, they could change everything we know about volcanoes, earthquakes, and the magnetic field that protects us from deadly space radiation. They might even reveal how much time our planet has left. Every single day, you walk on a thin shell of rock floating above an alien world. A world of crushing pressure, temperatures hotter than the surface of Venus, and forces so powerful they can move entire continents like pieces on a chessboard. For centuries, this hidden realm was pure mystery. But now, cutting-edge science is revealing secrets that could save lives, predict disasters, and unlock the energy of the future itself. Today, we're going on a journey to the center of the Earth. We'll discover what scientists have found down there, and why it matters more than you might think. Our story begins with what seems impossible. The ground beneath you is moving. Right now, as you watch this video, North America is sliding westward at about the speed your fingernails grow. The Himalayas are rising higher. The Atlantic Ocean is getting wider. This is plate tectonics, Earth's surface broken into massive puzzle pieces that drift on a sea of molten rock. When these plates collide, mountains are born. When they separate, a new ocean floor is created. And when they suddenly slip past each other, earthquakes. The San Andreas Fault in California moves about 2 inches per year. That doesn't sound like much until you realize all that motion builds up stress, and eventually something has to give. But plate tectonics is just the surface story. To understand what scientists have recently discovered, we have to go much, much deeper. 100 miles below the surface, rock becomes so hot it starts to flow like thick honey. This is magma, Earth's liquid engine of creation and destruction. Take Yellowstone, what tourists see. Geysers, hot springs, bubbling mud pots, is just steam escaping from something monstrous below. A magma chamber the size of Rhode Island, filled with partially molten rock. Scientists call it a mush reservoir, and it's been building pressure for thousands of years. But magma isn't just destructive. It's how our planet breathes. Volcanoes have been recycling Earth's atmosphere for billions of years, releasing water vapor, carbon dioxide, and the minerals that make life possible. Without volcanoes, we wouldn't exist. And here's where the story gets really interesting. To study what's happening deep inside Earth, scientists have learned to use the planet's most violent moments as a kind of medical scan. Every earthquake sends shock waves through the entire planet. These seismic waves travel at different speeds through different materials, slowing down in liquid, speeding up in solid rock, bending around obstacles. It's like using earthquake energy as a massive X-ray machine for the entire planet. And over decades of recording these waves from thousands of earthquakes, scientists have built up a picture of what's hidden inside Earth. This isn't just academic curiosity. The same technology that maps Earth's interior now gives us earthquake early warnings. In Japan, bullet trains automatically brake when sensors detect the first seismic waves. In California, phones buzz with alerts, seconds before the shaking starts, giving people precious time to take cover. But recently, this global network of sensors has detected something no one expected to find. Meet the blobs. 2 massive structures, each larger than all of Europe, sitting at the bottom of Earth's mantle like sleeping titans. One beneath Africa, one beneath the Pacific Ocean. Scientists call them large low-velocity provinces, but that doesn't capture how strange they really are. These blobs are hotter and denser than the surrounding rock. They might be remnants of ancient impacts or material from Earth's formation 4.5 billion years ago, and they could be the secret source of the most dangerous volcanoes on our planet. Remember Yellowstone? Scientists think its magma might be fed by hot rock rising from one of these deep blobs. The same could be true for other supervolcanoes that could devastate civilization. But the blobs weren't the only surprise. At Earth's very center, the inner core, a solid ball of iron and nickel under crushing pressure, seismic waves revealed something impossible. The inner core appears to have its own inner core, a sphere within a sphere, with crystals aligned differently, like a Russian nesting doll made of metal. It's as if Earth's heart has a heart of its own. And then came, perhaps, the most unsettling discovery of all. The core might be cooling faster than we thought. Heat is escaping from Earth's center into the mantle more rapidly than previous models predicted. This could affect our planet's magnetic field, the invisible shield that protects us from deadly radiation from space. Without a strong magnetic field, Earth could end up like Mars, a cold, dead world stripped of its atmosphere by solar wind. Understanding these deep Earth processes isn't just fascinating, it's essential for our survival. That's why every October, thousands of schools, museums, and communities across the country celebrate Earth Science Week. This year's theme is Geoscience for a Resilient Future, and it couldn't be more relevant. From October 13th to 19th, 2025, geoscientists are sharing discoveries that could help us predict volcanic eruptions, improve earthquake warnings, and find sustainable sources of energy buried in the Earth. The same deep Earth research revealing those mysterious blobs and core structures is also mapping geothermal energy sources that could power our cities cleanly for centuries. It's identifying where we can safely store carbon dioxide to fight climate change, and where we can find the rare earth minerals essential for renewable energy technology. Earth Science Week reminds us that every citizen can be part of this discovery. From backyard geology to citizen science projects, we're all connected to the restless planet beneath our feet. Right now, artificial intelligence is analyzing seismic data faster than ever before, revealing patterns human scientists might miss. Satellites are measuring ground movement down to millimeters, watching for signs of impending eruptions or landslides. Every new discovery about Earth's deep structure brings us closer to predicting its dangerous moods. The blob under Africa might help us understand why the East African Rift is slowly tearing the continent apart. The cooling core could reveal how long our magnetic field will protect us. These aren't just Earth science questions anymore, they're space science questions too. As we plan missions to Mars and look for life on other worlds, understanding how planets work, how they generate magnetic fields, and how they die becomes crucial for humanity's future beyond Earth. The next generation of geoscientists will use quantum computers to model Earth's interior, drill deeper than ever before, and maybe finally solve the mystery of those continent-sized blobs lurking in our planet's depths. So the next time you feel solid ground beneath your feet, remember, you're standing on the thin skin of a dynamic, mysterious world. A world where continent-sized blobs of ancient rock drift through an ocean of molten metal, where the very heart of the planet pulses with secrets we're only beginning to understand. 4,000 miles down, in crushing darkness and impossible heat, Earth keeps its greatest secrets. But human curiosity is relentless. We send our instruments deeper, our computers grow more powerful, our understanding expands. And who knows? The next seismic wave, the next data analysis, the next brilliant insight from an Earth Science Week participant might reveal something that changes everything we thought we knew about the planet we call home. What do you think we'll discover next in the depths below? Let us know in the comments, and don't forget to subscribe for more mysteries from the world of science.